Basic electronics. Unit 1, introduction, electrical signal frequency spectrum signals. And then introduction electronics, module 1. Electronics is a branch of science engineering dealing with the theory and use of glass devices which in electronics and transported through a vacuum gas or semiconductor. Signals. It contains information about a variety of things and activity. Example of voice, radio, announcer, weather information, analog signal. Signal magnitude can be represented any instant of time by a sequence of numbers. Discrete signal is a sequence of numbers that represents magnitudes of successive signal samples. Your digital signal is a form of zeros and ones. We have an amplitude volt over time and an amplitude signal, amplitude volts and digital signal. And then we have X amount of T to T. Frequency spectrum of the signal. Arbitrary signal is characterized as frequency spectrum. The signal is represented with a frequency domain. Fourier series expansion periodic symbol linear combination sin and cosine different frequencies and amplitudes applied over the periodic signals. Fourier transformation. Fourier transformation can be applied to a periodic signal to find the frequency spectrum. Low-pass filters. The filter passes the low-frequency components of the signal, rejects the high-frequency components of the signal, is called the low-pass filter. Filters designed with passive components, resistor, capacitors, and inductors are called passive filters. So your resistor, capacitor, and inductors are called passive filters. Behavior capacitor of a frequency can be described as the following. Low frequency for low F equals 0, low frequency capacitive reactance is capacity of the reactance over volts over amps equals amps times 2 times F to the capacitation equals infinity, so on in an open circuit. F equals infinity, high frequency capacity, reactance, capacitor, and capacity, voltage, amps, and equals 1 over 2 times frequency. Capacity equals 0, so it acts as a short circuit. Low frequency open circuit, high frequency short circuit. Operation low frequency since capacitors are open circuit. For low frequency since capacitors is an open circuit, current flowing through the circuit is 0. So the output voltage output equals voltage input. High frequency single capacitor short circuit, but the output voltage across the short is 0. So the output voltage output is equal to 0. Frequency response curve is shown below. You have voltage of 0.707 volts, and then it lines out at frequency capacity, pass band, stop band, frequency log scale. Calculation cutoff frequency voltage output is equal to capacity times resistance times over capacity times voltage input. Voltage output absolute value is equal to capacity over resistors 2 and resistance 2 times capacity times 2 times the absolute value of voltage input. If resistance equal to capacity, voltage output is equal to 1 over 2 to the squared times voltage input, or 0.707 voltage input. A frequency in which the resistance equal to capacity output, of which 70.7% of the input voltage capacity is equal to resistance equals to 1 times 2 times pi times frequency capacity cutoff frequency. Cutoff frequency is equal to 1 over 2 times pi times the resistance times the capacity. The LPF circuit integrator. Output voltage currently directly proportional to integration of the input voltage current. The time of the resistance and current of the circuit should be very large as compared to the time of the period of the input wave. The value of the resistance should be 10 more times larger than the capacity. High frequency of the capacitor insufficient to charge up the voltage is small, so the voltage across the resistor approximately equal to the input voltage. Voltage input, voltage resistance, amp is equal to voltage resistance over the resistance. Equal to voltage input over the voltage resistance. Change in Q character if an instant Q is somehow related to IDT. Output voltage output, voltage capacity equals voltage capacity. The charge is equal to the capacitation logarithm IDT over the capacity equal to 1 times the resistance current over the logarithm voltage in distance and time. High pass filter block low frequency component signals bypass high frequency components of the signal is called a high pass filter. Low frequency components signal passes high frequency component signal is called a high pass filter. Filters designed in passive components, resistor, capacitor, and inductor are called passive filters. Shows voltage in, voltage out, and shows capacitor and resistor and its ground operation. For low frequency, since capacitor is open circuit, current flowing in the circuit is 0, so the output voltage resistance is 0. High frequency single capacitor short circuit output voltage output voltage resistance equals voltage input. Frequency response can be shown as below. This is a high pass filter and its frequency cutoff at 3 decibels. Calculation of cutoff frequency voltage output over the resistance times the capacity times the plus. Alright, voltage output is equal to resistance times the resistancy over resistancy capacity times voltage input. Voltage output absolute value is equal to capacity over the square root of resistance times the capacity times 2 times the absolute value and voltage input. If resistance is equal to capacity, voltage output is equal to 1 over 2 squared over the square root. Voltage output is equal to 1 over the square root of 2. Voltage input is 0.707 the voltage input. Frequency with the resistor and capacity output is 70.7% over the input with the capacity equal to the resistance over the 1 or 2 pi times the frequency times the current. Cutoff frequency equal to 1 over 2 times pi times the resistance times the current. HPAF differentiator. Output voltage current is directly proportional to differential input voltage current. Time constant with the RC of the circuit. Resistor capacitors of the circuit should be very small compared to the time period of the input wave. Value of the resistor should be 10 more times smaller than the capacity. The high frequency of the capacitor has enough to charge up. Some of the voltage across the capacity is approximately equal input voltage. Voltage input voltage equals voltage capacity of the charge of the capacity if it is in any instant of the output voltage output. The charge at any instance is charge is equal to current over the voltage current capacity. Output voltage output in amps. Resistance distance of the charge and time times resistance equal to current resistance. Distance to voltage capacity, distance time equal to current resistance to voltage in amp the voltage time. Semiconductor N lies between the conductor and insulator. Forbidden energy given a gap of 0.2 to 2.5 E volts or 0K. Pure semiconductor, perhaps insulator semiconductor materials show reduction in resistance with increase in the temperature, so said to have a negative temperature coefficient. Intrinsic semiconductor refinement. The numbers of the impurities very low levels of semiconductors. Pure form group 4 elements silicon and GE element GE eccentric semiconductor. To increase conductivity, impurities also called a dopant in groups 3 and 4 are added to the pure semiconductor material called intrinsic semiconductors. Negative and positive type. This process is called doping. Negative type, the semiconductor pentavalent is AS, SB, and P atoms is added to the pure semiconductor. Fused impurities, fire valence electrons are called donor atoms. Positive type and semiconductor trivalent aluminum Ba and Ga elements atom is added to pure semiconductor. Fused impurities with 3 valency electrons are called acceptor atoms. So we have donor atoms and acceptor atoms. Shows an anonymity and the SB impurity. Doper ions are positive. Major carriers, minority carriers, negative type. Major carriers. Acceptor ions, positive type, minimum carrier. Holes are in the majority of the carrier of the positive type semiconductor electrons with the minority carrier with the negative type of the semiconductor electrons majority carrier and holes minority carrier. A diode is a solid-state device created by the joining positive type and negative type material is called a semiconductor diode. No bias voltage, 0. Absence of external voltage across the positive and negative junction is called the unbiased diode. However, the density of gradient electrons hold the diffuser. They combine, leaving the ions unneutralized. They are called uncovered charges. If the uncovered charges generate electrical field directed by the negative side into the positive side, called the barrier field, which outputs of different fusion processes further sends vicinity of the junction to deplete with the mobile charges, hence called as a depletion region. So we have positive type and their negative type, a depletion region, acceptor concentration, donor acceptor concentration, and that is across ways a low concentration, a electron concentration, positive square charge, negative square charge, barrier field. Then we have a voltage, and E must 0, reverse basis voltage D. Voltage diode is less than 0 volts. Positive polarity of the external base of the voltage diode is connected with the negative type of the negative terminal with its connected with the positive type. Number of uncovered positive negative ions will increase the depletion region called with the widening of the depletion region, which creates a barrier with a majority carrier to overcome an efficient reducing majority carrier with a flow of 0, hence the current due to the majority is amperes majority is equal to the derivative of the minority carriers which travel down upon potion potential barrier remain unaffected given the small current called the reverse saturation current, denoted as amperes S or S. Forward bias voltage diode is greater than 0 volts. Is forward bias. Positive polarity external base voltage diode is connected with the positive negative terminal is connected to the negative terminal. External bias of voltage diode exerts the force of the mobile characters to move it towards the junction at a boundary that recombine with the ions, reduce the width of the depletion region. Depletion region will continue to decrease and the width of the voltage is increased with further heavy flood electrons will move with the negative side to positive side, giving the ampere majority and exponential rise to positive side to the negative side. A minority carrier flow will be not effective for this because of the conductive level is determined the limited number of impurities in the material, and the current is denoted as ampere saturation. Total current is given by amperes diode equals amperes forward plus amperes reverse equals amperes majority minus amperes minority, direct opposite. Terms reverse saturation current ampere diode can be written ampere diode amperes saturation exponential E volts over the NKT, called the Shockley equation. E is the change charge of the electron. K is Boltzmann content, and T is the temperature in Kelvin. N is the quality factors depending upon the diode material, and V is the supplied voltage across the junction. And it shows a little period right there. Breakdown condition 0, the Zennir breakdown. Too much of reverse bias across the positive and negative junction exerts strong force on the bound electron tear out with the covalent bond, and a large number of the electrons whole pair will be generated through the direct rupture of the covalent bond. This increase of the reverse current gives sharp increase to characteristics is called the Zennir breakdown. Diode employing unique portion of characteristic positive and negative junctions called Zennir is called the Zennir diode. Maximum inverse voltage potential can be applied before the entering the Zennir region. It's called the peak inverse voltage, PIVR, or peak reverse voltage. Avalanche breakdown. We increase reverse voltage, bias voltage electrical fields across the junction diode, increase a certain value of the reverse voltage electrical fields, impart sufficient high energy to the thermally graduated carrier. Carrion colliding with an ion ways disrupts a covalent bond, give it a new whole electron pair with the process cumulative to give it the avalanche of the carrier with a very short time is called an avalanche multiplication. Diode equivalent circuit combination element properly chosen to the best represent the actual terminal characteristics of the device or system particular operation point. Then we have the diode equivalent circuit models, piecewise linear model, simplified model, and ideal model. Ideal diode of forward and reverse bias condition as follows. It shows the voltage diode and the ampere current amp voltage diode negative positive, and it shows a switch. Diode resistant level. According to the applied signal resistant level, the diode have the following type: DC or static DC signal, ACE2, AC or dynamic small AC channel, or 3 average average AC large AC signal. And those can be represented by the DC or static resistance diode over voltage diode over amp, defined as a point of the characteristics. AC or dynamic resistance defined as voltage diode over ampere diode and 26 millivolt ampere diode. Find as a tangent line on the Q clump on the charge point. Average AC resistance average AC defined as a straight line between the limits of the operation. Clipper. It controls the shape of the output waveform by removing or clipping a portion of the applied wave. The half-wave rectifier simplifies example is also referred to as voltage limiters and applied selectors and slicers. Application of radio. Receiver the communication circuit of the radio, digital computers, other electronics for the generation of a different waveform with a trapezoidal square wave helps and process the picture signals of the television transmitter. Television receiver the separate synchronizing signals from the composite picture signals. You have forward tuning diode and a reverse turning off diode. The switch is closed, switch is open on the reverse turning off diode. Types of Clipper circuit series. Diode is in a series with a source. 2 parallel diode is parallel with a source. Clipper circuit is which the AC battery is called a bias clipper. Series clipper assumption as ideal characteristics. An analysis of a positive voltage half cycle of the diode become with a forward biasing condition. Since no voltage drops off the diode, output becomes voltage output equals voltage resistance times voltage initial voltage amperes. The diodes of the also become with a reverse bias conditions. If no currents flow for the circuit, output voltage output is equal to 0. Figures show output waveform simple series clipper with the input square with the end of the triangular waveform. Since the negative half cycle is clipped off of the output is called the negative clipper circuit. Bias series clipper assumption diode is an ideal characteristic analysis. Since the diode, because of the 5-volt battery transition diode, one state with another, can be found out of the voltage N. Voltage I equals negative 5 volts above the diode on, before which of the diode is off. The half voltage efficient effort is since the diode's output voltage will apply with the KVL is voltage output plus voltage I plus 5. Voltage half cycle since the diode is off, the voltage output is 0. Figures show the input output waveform examples of other series and circuits. So sample series clipper ideal diodes positive and negative, and then bias series clippers ideal diodes, and then it shows these 4 different ones. Parallel clipper assumption diode is an ideal characteristic analysis of the voltage half cycle of the diode, often with a forward biasing condition. Since no voltage drops off the diode, output voltage output of voltage diode is equal to 0. Voltage AE that was reversing the bias condition of the non-current flowing through the circuit of the output voltage amps. Show the voltage input output with the simple of the input is square with a triangular waveform. Positive half cycle clipped off of the output is called the positive clipper circuit. Bias parallel clipper assumption diode is in deal with the ideal and characteristic. Analyze transition with the diode from one state to another can be found in the voltage input for voltage initial 4 volts above the diode off and below the diode is on. Half cycle, since the diode is off, the output voltage will be voltage I is equal to voltage output, voltage E with E, negative VE. Half cycle, since the diode is on, voltage output equal to 4 volts. Show the input output waveform. Example of the other parallel clippers, we have simple parallel clippers, ideal diodes, simple parallel clippers, ideal diodes. clampers. A diode capacitor can be combined with a clamp at an AC signal specified DC level. Most have the capacitor with a diode resistant element with addition with a chip with an independent DC supply introduced into the circuit. The time of the constant is time constant equal to the resistance of the current must be large enough to ensure the voltage across the capacitor or the resistance capacity capacitor does not short significantly during the diode and non-conducting. Procedure to analyze a clamper circuit can 1. Consider part of the input signal with a forward bias for the diode. 2. During on state, assume the capacitor will charge the output instantaneously to a voltage level determined by the network. 3. Assume that during the diode is on an off state, the capacitor will hold on its established voltage. 4. The point of voltage output must be the same through the analysis. Total swinging of the total output must match the swing of the input signal. Voltage clamper analysis. Diode is on short circuit positive with half cycle with established voltage level of the voltage capacitance equal to voltage. During the negative half cycle of the diode is off, the voltage output, the output of the voltage output, voltage resistance over the negative voltage input times voltage current capacity equals negative 2 volt total swing, negative 2, which is the same as the total swing and input. You have a bias clamp circuit, and this is digital and half cycle of the diode on with a KVL around input loop. During half cycle, the diode is off. Apply KVL around the outside of the wire. We have voltage output 0. Summary of the clamper circuits. We have a clamping network. Rectifiers important application. Regular diodes, rectification circuit. These circuits are used to convert AC signal to DC power supply. Block diagram process of the DC power supply is shown below. We have a power transformer AC line, 120 volt root mean squared, 60 hertz. Voltage saturation, positive and negative diode, and we have the time constant, the constant diode rectifier, filter, voltage regulator, and load over here at amperes voltage load, positive and negative. Half-wave rectifier shows a resistance on the diode. Above the circuit is a half-wave rectifier. Since the generator of the waveform will have the average value of the particular use of the AC-DC version process. During 0 positive half cycle, the diode is on, assuming the ideal with no voltage drop across the output voltage will be voltage output voltage resistance over the voltage M. During the negative half cycle of the off open circuit with some of the current flowing through the circuit, it will be 0. The output voltage will be voltage output voltage for resistance times initial, or amperes times resistance equals 0. Voltage resistant and initial and times resistance equals 0. Show input output waveforms output voltage DC. Disadvantages: AC supply delivers power on only in half the time. Pulsating AC power delivers power only half the time. Pulsating current frequency is equal to the supply frequency. Full wave rectifier. Full wave rectifier utilizes positive and negative portion of the input waveform. Typical type of the full wave rectifier: center tap configuration, big configuration. Center tap configuration shown as a transformer coil, iron transformer coil, 2 diodes with a resistor going back with a positive voltage input. Current flows through load resistance same direction during the full cycle of the input cycle of the center tap transformer into the second winding. Half cycle of the diode 1 show the short circuit, diode 2 open circuit. Current flows through the upper half of the secondary winding. And then half cycle diode 2 short circuit diode 1 is open circuit with current flows through the lower half of the secondary winding. Complete input output waveforms can be as shown. Full cycle rectifier, big improvement of over a half cycle rectifier. There are some of the disadvantages. Difficult to locate center tap of the secondary winding. Diodes must have a PIV. I forget what that means. High PIV. Bridge rectifier uses 4 diodes connected with a bridge pattern. So the diodes and resistors are 1, 2, 3, 4 squared out. And that's an AC connection. Operation bridge Rectifier summarizes half cycle of the diode 1, diode 3 or short circuit diode 2, diode 4 or open circuit current flows through diode 1, 3 to give output voltage across the resistor. Half cycle diode 1, diode 2, open circuit with diode 2, diode 4, short circuited current flows with diode 2, 4, and diode 4, giving output voltage at the resistor across the resistor. Complete input output waveform can be shown. And then advantages: no center tap transformer is required. PIV is less. Advantages: it's required 4 diode power loss rectifier element is more. Module 2.